A large study tracked the amount of coffee consumed in one day by coffee drinkers. The data seems to follow a normal distribution. The average number of ounces consumed in one day by the coffee drinkers was 27.9 ounces, and the standard deviation for these values was 7.5 ounces. Assuming the results of this study are representative of the coffee drinking population, find the amount of coffee consumed by the bottom 6% of coffee drinkers. All right, so again, the problem says the data is normally distributed. They normally would ask you for either a probability or a measurement that corresponds to some percentile. And they ask us to find the amount of coffee consumed by the bottom 6% of all coffee drinkers. So it looks like it's the type of problem where they give us a percentile and we have to find the measurement that's associated with that percentile. Okay, let's draw a bell curve as a visual aid, and we'll label a z-axis centered at 0 and x-axis centered at the mean, which is 27.9 according to the problem. And then we'll label the standard deviation up here as 7.5. Okay, let's go ahead now and decide what part of the curve we're working on. Could it be that we're working on this side of the curve? Could it be that we're talking about the bottom, which would be the lower 6% over here? But this wouldn't be just 6%, right? This would be more than 50%, right? It's impossible for that to be just 6% since one whole half of the curve is 50% already. And this is more than half of the curve. So it can't be that they're referring to. So that doesn't make sense to say we're working on the right-hand side of the curve. We must be therefore working on the left-hand side of the curve. So this must be 6% here. This is the bottom 6% we're referring to. And from there, that means we need to find the corresponding z-score that's located here, and then the associated measurement that corresponds to that right here. Okay, so if this is 6% in the tail, what's the area from here to here first, and why do I care about that area? Well, I care about that area because that's how our z-table works, right? We're trying to find an unknown z-score here, and that z-score is going to be associated with this area because that's how the table works. It works from the line you look up to the center. It does not give you areas for the tail regions. That's not how our table works. So I'm going to have to look up the area that's here. How do I know that area? Well, I know the tail is 6% according to the problem, which means this must be the leftover 44%. Why 44%? Because 44 and 6 add up to 50, and that would cover the total area for half of the curve. So that makes sense. Now, as a decimal, that's going to be 0.4400. Okay, so let's go look up 0.4400 on our z-chart and get our corresponding z-score. But before we go do that, to develop good habits, we might want to get in the habit of saying, hey, whatever answer this is, it's going to be negative at the end because it's to the left of 0. The table doesn't give you negative values, so if you don't do that before you leave, you could very well make a mistake. Okay, so let's pull up the z-table and see what we get when we look up the closest thing to 0.4400. All right, so again, we're looking in the body of the table, right? We're looking here, not elsewhere, right? Okay, so let's look for 0.44. Well, here's 4452. Let's look up 0.44 in this row then, see if we can get closest to it. All right, so this is really close. That's about 6/10,000ths of the way, but then guess what? This is also 6/10,000ths of the way. Whenever that happens, the simplest way to handle it is to take the smaller position, and that would be the one to the left here, and it's going to be 1.501234.5. So that's 1.55, right? Let's keep that in mind that it's 1.55, and I'm going to write that down, 1.55, but I'm going to add a 5 at the end of that number, because essentially we were right between the position 1.55 and 1.56. So since we were right in the middle, I'm going to take the number that's right in the middle of those two values, which would be 1.555, right? Because right in the middle between any two numbers is going to be another 5 added to the end. So anytime you end up getting an area that's right between two z-scores and there isn't a closer value, you're just going to take the smaller z-score and add a 5 to the end of it. Right, so if you were stuck between 1.64 and 1.65 on the table, you would take 1.64 and you would throw a 5 at the end of it, and it would be 1.645, your answer. Okay, so our answer is 1.555. Now, let's go ahead and plug that into our formula now to get x. The formula for x is just the z-score solve for x. So the z-score formula solve for x is x equals to z times sigma plus the mean. So in this case, that's going to work out to be negative 1.555 times the standard deviation, which is 7.5, plus the mean, which is 27.9. All right, let's see what that gives us. So we'll have negative 1.555 times 7.5 plus 27.9. and that ends up giving us 16.2375. Let's just round it off to a whole number, or to one decimal place, 16.2 ounces, we'll say. So about 16.2 ounces of coffee is the cutoff between the bottom 6% and the rest of the group, right? So people in the bottom 6% drink 16.2 ounces or less coffee per day. So roughly about 2 cups.